Anyone who's worked in a team on Linux knows that managing who can access what is absolutely critical. So today, we're diving into two of the most important tools for making that collaboration seamless and secure: UMask and group permissions. Let's get right into it.
So let's start with something I bet you've all seen. You create a new file, you check its permissions, and you see this: rw-r-r-. Why that specific combination? You know, it might seem totally random, but it's not. It's actually the result of a very deliberate system working behind the scenes.
And that system is called the UMask, or the user mask. This is the engine that controls the default permissions for every single new file and directory you create. And understanding UMask, well, that's the first real step to mastering file access in Linux. So what is it exactly? The UMask is just an octal number, like 022, that acts like a filter. But here's the key thing to remember. Instead of adding permissions, it actually removes them, or masks them, from a default starting point. It's all about taking permissions away. To get what UMask removes, you have to know where Linux starts. The system begins with a set of base or maximum permissions. For files, that's 666, which means read and write for the owner, the group, and everyone else. For directories, it's 777, which adds the execute permission for all three. This is basically wide open access before any restrictions get applied. The calculation itself is actually just simple subtraction. So let's take a really common UMask, 022. If you create a new directory, Linux starts with that base permission of 777. Then it just subtracts your UMask of 022, and the result is 755. And that translates to full permissions for you, the owner, but only read and execute for your group and for everybody else. And you can see here how different UMask values create totally different security levels. That default, 022, is pretty collaborative. It lets other people read your files. A value of 027, though, is more restrictive. It locks out others completely, but still lets your group have some access. And 077? That's for total privacy, creating files that only you, the owner, can get into. So, what's your system's default setting? It's super easy to check. Just open up a terminal and type UMask. Most systems are going to show you 0022. And hey, that actually explains the permission we saw at the very beginning, right? The base for a file is 666 minus a UMask of 022 gives us 644, which is exactly rw-r-. See? It all connects. And you can change it just as easily. If you want to be a bit more strict with your permissions for, say, your current terminal session, just type UMask followed by the new value like 027. Any files you create from that point on in that session will use this new setting. But what if you want that change to stick around permanently? Well, to set it just for your user account, you'd add the command to your ./bashrc file. And if you want a system-wide default that applies to everybody, a system admin would edit the /etc/profile file. Okay, so UMask is awesome for setting our own individual defaults, but what about when we actually need to work together? That's where groups come into play. In Linux, every single file and directory has two key identities attached to it, an owner and a group. When you run the ls-l command, it shows you both of them, right there next to the permissions. This simple owner-group pairing is the foundation of Linux's entire multi-user security model. So let's say you've created a file, customers.txt, but now the marketing team needs to be able to access it. It's simple. You can change its group using the chrgp command, just like this, and reassign it to the marketing group. Done. An even more efficient tool, though, is chown, which stands for change owner, but it's not just for owners. By using a colon, you can change both the owner and the group at the same time. It's a fantastic one-liner for managing both settings at once. All right, so here is the classic collaboration nightmare. You've set up a shared directory for your team, maybe called sales. You've correctly set the group ownership to sales, but then your coworker creates a brand new file inside it. What group do you think that file belongs to? By default, it's going to belong to their primary group, not the sales group of the directory. And just like that, your whole shared folder system falls apart. This is a massive headache, for sure. But thankfully, there is a professional-grade solution that automates this whole process and makes sure permissions are always correct. It's called the SGID bit. The SGID, or Set Group ID bit, is a special permission you can put on a directory, and when it's set, it totally changes the default behavior. It basically tells Linux, hey, ignore the user's primary group. Any new file created here must inherit the group of this parent directory. It's like a rule that can't be broken. And applying it is incredibly simple. The command is just chmod g+s on your directory.
The G is for group, the plus sign adds the permission, and that little S sets that special SGID bit. That's all there is to it.
And with that one command, you've completely solved the shared directory problem. From now on, it doesn't matter who on the team creates a file inside /sales, it will automatically belong to the sales group, making sure everyone with the right permissions can access it, every single time. This is truly the key to managing collaborative projects on Linux.
So we've covered a lot of ground. Let's do a quick recap of the most important points and highlight some common mistakes to avoid so you can put this into practice without any headaches.
First, always remember that UMask subtracts or removes permissions. It never adds them. Second, for collaboration, just setting file permissions is not enough. That file absolutely must belong to the correct group. And finally, for any shared team folder, not setting the SGID bit is a recipe for total permission chaos down the line.
I love this quote from the source material. It's a perfect way to remember how unmask works. Think of it as an undo value. It reverses that default of maximum access, and it carves out only the permissions you don't want your new files to have. So remember, UMask, group ownership, and SGID, they aren't just abstract commands. They are your toolkit for building an automated and secure permission strategy. So the real question is, how are you going to use them to streamline your next project?